Alright, in this last part we're going to be looking at the negative exponent rule, which notice I have a question here. What is the negative exponent rule and how do you use it? And the negative exponents in the numerator become positive when moved to the denominator, and negative exponents in the denominator become positive when moved into the numerator. So in case you're wondering what I mean, let me give you an example. If I, for instance, had 1 over x to the negative 1 power, if I move this up to the numerator to make it x to the power of 1 over 1, notice that power of 1 became positive. I'll give you another example. Let's do another one. Let's say we had 3 over y to the negative 2nd power. If I move my y up to the numerator, it would become 3 times y to the 2nd power. And I'll give you one more example. Say I had x to the negative 2 power over 1. I could simply move this down to the denominator, which would then leave me with 1 over x to the 2nd power. So, whether you move one from the denominator to the numerator to make it positive, or from the numerator to the denominator to make it positive, it basically has a sign change every time you move it up or down. Now, this also works vice versa. For instance, let's say that this x to the negative 2 was on the denominator, right? If we move it up, it becomes positive. If we move it back down, it becomes negative again, and vice versa. So let's go take a look at some of these problems and kind of use this idea of us being able to move the variable with its power either to the numerator or denominator in order to change its sign, either positive or negative. Now, the reason this is important is that all final answers must always have a positive exponent. It has to be positive or it's wrong. You cannot have a final answer with a negative exponent. So let's take a look at this first example. Notice we have x to the negative 10 divided by x to the negative 3rd. So we're going to use the quotient rule to solve this. So I'm going to go ahead and write this out. So what I have here is I have x to the negative 10 minus, because remember we always put our numerator's power first and then our denominator, minus negative 3. Now you do have to remember you have to distribute that negative sign, which means that this negative 3 now becomes a positive 3. So it's negative 10 plus 3. Well, if we were to finish working this out, we would end up with x to the negative 7. Now remember I said we cannot have a final answer that's negative 7 on our exponent. So what do we have to do? Well, we would have to send this down to the denominator. And so in other words, we would say instead of x to the negative 7 power for answer, it would be 1 over x to the positive 7. And if you're wondering, well, how did you do that, Mr. H? That looks magic. You just changed it from a negative 7 to 1 over x to the power of 7. No, what I did is I recognized that x to the power of negative 7 over 1. I recognized that that's over 1. And I simply just took this on top and moved it to the denominator. Now remember that our coefficient of x, we have an imaginary 1 up here. In front of x, there's an imaginary 1 for its coefficient. So when I moved x to the negative 7 down, it leaves us with 1 over x to the positive 7, which is our answer. So I hope that makes sense. And if it doesn't, just keep watching this and you're going to see me do another example. And I think the more I do, the more it's going to make sense to you. So here we have 1 times x to the power of negative 8 over 2. Now, if we're going to go ahead and work this out, I recognize, just like in this situation, I have a coefficient of 1. And x to the negative 8, in order to make that positive, all I have to do is move it to the denominator. So then this final answer becomes 1 over 2 times x to the power of positive 8. So maybe this one was a little bit easier to see than this first one. All I did was take this x to the negative 8, move it to the denominator, and it become x to the positive 8. Let's try this last one now. Okay, in this last one, the first thing that I notice is that I have a 15 in the numerator and I have a 3 in the denominator. So I know, okay, well I know how many times 3 can go into 15. 3 can go into 15 5 times. Then I look at it and I go, well, you know what, looking at these down here, these are both negative powers, but there's no variables on top. So I can actually use my definition of a negative exponent rule, and I can just simply move that x to the negative 2 up on top to the numerator. And I can move the y to the negative 4 up on top as a numerator, and that'll change both of those positive. So my final answer would be 5 times y to the positive 4, because when it moved to the numerator it became positive, and then I can say times x to the positive 2. And that is my final answer. Now some of you might be looking at this going, Mr. H, why did you move the y in front of the x? Well, look at the y. It has a power of 4, and the x has a power of 2. And remember I told you, always write these where the highest power is in front when it comes to the variables. So that is my final answer. 5y to the power of 4 times x to the power of 2.